Good morning, everyone. I'll try to make this as light as possible for the early morning start of the tech day. As you're probably familiar with this template since it was yesterday also here. I'm Jagor. I run security ops at Erste Group Car Processor. One of my tasks, my daily tasks, is to run HSMs, and I would like to share my how my daily operations on HSMs look like. So what I'm going to talk about, generally why HSM, what HSM is. So I will talk about a bit about SSL HSMs, payment HSMs, and daily operations. That is going to be the bigger part of the presentation. And I will talk about something about how to make your HSM farm compliance. And of course, questions in the end, if there are going to be some. So, why HSM? First, what is HSM? It's a hardware security module. The idea is very simple, actually. Keep your keys in some tamper-proof box that is going to be much more safer than storing keys on any kind of other device. Is it a server, is it a router, whatever. Protect your keys from memory scraping. Is it doesn't matter, the keys are on disk or on memory. This way you can make sure whoever owns your box can't get to your keys. And also protect your keys from physical theft. Most of the HSM devices have some sort of protection from physical theft, so nobody can get into your data center and simply plug the device out. There are some basic classifications. We have SSL HSMs, payment HSMs, point-to-point devices for encryption, and some other specialized devices, but I'm going to talk only about SSL and payment, since this is the most common use, and I think it's most interesting to the people here, actually. So, SSL HSMs, what for? Storing private keys. In most configuration of HSMs, SSL HSMs, you can store pretty much as many keys as you want. Numbers are like up to 2 million or something like that. And the basic idea is private keys should never exist outside the HSM module. You create keys in HSM module, you generate CSR or something for export, but key itself, the private key itself, never leaves the module. And in the end, your Apache server or whatever you're using will, for each SSL request, will ask HSM, okay, could you please decrypt this? And HSM will return a response. And whatever happens, the key stays in the box securely. That's at least the idea. So the good thing, no memory scraping will help attacker if your machine gets owned. Your keys are safe, basically. Fun fact, well, hard bleed for us wasn't really such a big problem. Some certificates needed replacing, but all our keys were safe, and it wasn't any drama. And the bad, there is a lot of bad. Patching. When you buy HSM, you get the box, and you get some API, and you get also probably some source codes for patching, like Apache server. That basically means that in pretty much most cases you will have to compile source yourself and put it into production. So if there is some bug in Apache, vulnerability, whatever, and you have a rather quick life cycle of putting things in production and newly features, you will have your pretty much handful. Debugging can be a pain. And point of failure. All your keys are in the box, and well, if box fails, you lose your keys. You can all HSMs have some sort of features to back up the keys, but if you have no box to restore the keys, well, bad luck. So basically you have one production active, you have one production backup, or in active mode depending on your setup, and most likely you will have to have one test machine. So that's three machines, and that's quite expensive actually. How about form factor? The bigger boxes are standalone devices that are available on the network. Smaller ones are PCI Express cards that you put in your server, and in contents of functionality, there is not that much different when we are talking about SSL HSMs. And we're actually in the company, we're working on some idea. HSMs are very expensive pieces of equipment. And the question remains how to fully utilize that very expensive piece of equipment. And in some cases, you do not need that much throughput and performance. So we're toying around with PKCS11 enabled USB sticks that could possibly use as low cost and low performance HSM, SSL HSM. If somebody has an idea how to make this thing work, you can contact us and we can share some information. SSL HSMs are run-of-the-mill thing and pretty standard stuff. But in our company, we use mostly payment HSMs. They're a bit different devices. They cover all encryption necessary for the payment to go through. When you put your credit card in ATM or POS device, all encryption that is done is covered by HSM or POS ATM device itself, and the whole communication channel is encrypted. Payment HSMs are specialized for symmetric encryption, and we still use triple S. Yes, there is no, in banking sector, triple S is the one and only thing still. And you use them for everything, for payment processing, for creation of EME keys for credit cards, and the whole credit card actual life cycle. And performance of these devices is defined by how much transaction per second can they do. Administration is done like any other physical appliance. Like we have a console, you have management board. That's actually rather simple part. And then there goes the most important. When you create your EMV keys or any other keys that is associated with credit card, they're all encrypted under one master key that is kept in the HSM device. And when you store your data in your databases, you have to ask for each transaction, you have to ask HSM, is this okay? Is this okay? HSMs are, for the most part, are devices that they do not have memory. They are just simple question and answer device. Is this pin okay? Yes, no. No other communications are necessary actually. And you keep your master key very safe, and you have only one master key for the most implementations actually. And there is a very important part that no key is ever available in plain text, either to administrator, to programmer, to nobody. You communicate with key encryption keys and some temporary keys, but keys that are on the credit card are never visible in plain text to anyone, and you cannot export it. There is simply no way. The master key itself is stored on 3 key cards or USB sticks, depending on the vendor. And on the Thales devices, for example, if you change anything in security configuration, you lose all data on the device, and you have to re-key device, re-upload the master key. And that can be quite a challenge to run if, for example, your data center is not in your same building. And again, you have to have at least 3 devices for stable production, and we'll see why. So daily operations. That was a bit of theory how the HSMs work. So let's see how to actually run them. Okay, you have your host that is connected to the HSM device. Brand new, lovely little box, and you need to operate it. First, you will have 2 security officers that have physical keys to the device. It's like arming a nuclear bomb. You have to turn 2 keys actually, and to make HSM capable of key loading facilities and all to have ability to load keys and create some other keys if necessary. In that moment, when you turn those keys, you cut the device from the network actually. So it's not anymore available for the your host that is doing online transactions, payments 24/7. The key itself, the master key, is stored on. The key looks like you're just another chip card, chip credit card. You have your key in 3 components. That means that you have 1 person more. Luckily, all the compliance standards says that the people who own the physical key can also own the 1 component of the digital master key. So you cut the device from the network. You must have at least 1 more so your production can keep running. You can change configuration, load keys, whatever you want on your device while production is running. And also, that's not enough actually. You cannot have production master key on your test environment. You have actually a specific test key that is used pretty much in all companies that use Thales devices. We all use the same test key, actually, test master key. So you end up with 1 more HSM device. So that's 3 again, at least. And that's not all. Since one of those 3 people can go to sick leave, vacation or something, you have to have backup of all people. So we're stuck now with 6 people involved in key management. Again, at least. So you can understand that if your HSM device, for example, is in some data center that is in another city, and you have to do the rekeying, at least 3 people need to go to the data center and do the job that probably takes about 5 minutes, but you still have to be physical there. Okay, now we loaded the master keys in the HSM. How do we communicate with some other entity? And there goes the, actually it's called key loading procession, because it has all the protocol, like some procession that you have to do before you can exchange keys with other entity. It was quite weird for me because I came from the other sector to the banking sector, and in the banking sector, PKI is not existing in all its forms. We still use a lot of symmetric encryption, and we still use, well, couriers for transferring papers with keys. So you will have 2 your security officers that will come to the HSM. They will authorize the device for creation of the keys. And they will have like your 3 some other employees that will get, each of them will get 1 component of the key. You will write them on the paper. Those 3 components will form the whole key. And then 1 by 1, they will send each day with a courier. Each day you send with different courier service keys to the 3 people in another company. Now that they received all 3 components, they can assemble their own key from their own side. You can, of course, exchange keys between different types of products. You use ANSI X9.17 standard for exporting keys. Now that you assembled the secure channel, and yes, when you put your paper in an envelope, it's a tamper-proof envelope, and they have to confirm, other side needs to confirm that the tamper-proof envelope wasn't tampered with. So we have to wait at least like 3 days is the fastest possible way to exchange that paper key. Now that you exchange paper key, now you can actually exchange the key that is going to be used for encryption of data. That's most commonly called zone PIN key and or key encryption key. Now you have a secure channel for communication. But in reality, we do not rely actually only on that one symmetric key. That is the last fallback. In reality, if two hosts are communicating, exchanging transaction data, then you have symmetric key. After that, you have SSL envelope, and in most cases, we will use a direct VPN connection to other hosts or even dark fiber in some cases. So you basically have 3 layers of encryption. The same thing actually goes for the POS devices and ATMs. ATMs and POS devices can be connected differently, but in the end, the same thing goes. If you want to connect your POS device to our authorizing system, you will also exchange that symmetric key that will be hard-coded into a POS device before use. And then POS device will connect via SSL or whatever to our host. And then POS device will send all the PIN data to HSM that will say, okay, PIN is okay, PIN is not okay, or create EMV authorization packets. And if you want to see that more, we have workshop after this. So we will create one PIN authorization workflow on the HSM itself. I have one here. HSMs are really expensive devices. So you want to utilize them as much as possible. They are secure, and we have a lot of data that we want to protect. And we found a way how to use actually payment HSM to protect our stationary data on our servers. So for the really sensitive data that we have, and we have a lot of sensitive data, like 5.5 million credit card numbers, and not only credit card numbers, but keys that are enough to create a chip on the card. We use payment HSM that is not probably originally intended to use in this way. Payment HSM has his master key. All our files are then encrypted by a separate key that then the key itself will be encrypted under master key. So if you want to decrypt a file, you have to ask firstly as HSM to decrypt a key encryption key. And in fact, it works quite well, actually. And all the auditors that were in our company in the last 3 years said that that's pretty good solution so far. We had actually some pen tests also of that solution, and it works. And if you own our box, well, you'll get a huge number of encrypted files, but you will have to break somehow the encryption of the HSMs to get to the data. And now, that's the usage of the HSMs, but there is a lot of limitations. And of course, there goes the compliance and the dreary world of compliance. So HSMs is really secure thing. You paid a lot of money to be sure that they are secure, and you hope they are secure. But the if you ask auditors of PCI PIN, PCI DSS, PCI card production, that's not enough. So if you buy HSM, then first get your vendor to send your serial number and the shipping number in advance, because if you do not have that, even like 15 years after you bought the device, not compliant. Inspect device before first usage and make a log entry. Also same thing, 10 years after, well, if you don't have that, not compliant. Also, upon delivery of the device itself, vendors should inspect the firmware. If you ask auditor what does that exactly mean, no response. If you change HSM's location from your one data center to another data center, you have to have a log entry about inspecting the firmware. Did the device get compromised in the van or truck or something like that? Also, all access to the key cards or USB sticks, depending on what you have, and those physical keys needs to be logged on the paper and kept in the vault. And also, before any usage, you should have log that you inspected the device itself. Those temper evidence sticks on the side of the device. But that's not all. You have two physical keys for the device, for arming the device, but that's not enough. So PCI PIN says that you have to have two locks on the rack where HSM is stored, but it doesn't specify what kind of locks they are. So you can basically put two luggage little locks on the rack, and that's perfectly fine. And also, you can have a problem. If you want to generate keys on the HSM, you have to put it in authorized mode, and that mode is not allowed in permanently. You have to have a log when you authorize the device for creation of the keys and when you removed it from that state. And also, key custodians should never be in the same business unit. That can be a problem actually if you run from a relatively small company, because remember you have 6 people that are involved in key loading. And also key custodians must never report to the same person. That's quite important, because that's, I would say, in theory protecting that some director will say to the employees, give me all the keys. And that's something that the auditors actually ask every time. And in the end, remote management. That's the fun part and the sad part, because each vendor pretty much has some form of remote management of the device. And I asked like 5 auditors in the last 3 years. Actually, we have remote management in a company. Can I use it to load keys? Because all the vendor says it's PCI compliant, and each auditor says no way. You can use it like to maybe look some statistics. You can use it to change smaller parts of the configurations. But remember, if you change anything big in the configuration, you will lose your all data, and you should rekey the device. So remote management, actually remote key loading, not compliant. Whatever the vendor said, we asked, yeah, for 5 auditors, can we use that? No, that's not the case. So if you have those devices and your data center is like 300 kilometers away, you have to count for long drives every now and then. Well, that's it from me. I hope it wasn't boring, and if you have any questions about running HSMs, feel free to ask. Anybody?